Okay, hello everybody. So yeah, my name is Joan Garcia. I work for Zeetta, and I'm going to talk to you tonight about today's networks, the problems we experience, and why they struggle to adapt to change. Okay. Whoops. So very briefly about myself and Zeetta. I'm a telecoms engineer. I'm born and bred in Barcelona, but I moved to the UK, Bristol, a few years ago to work on smart city projects, and that's the first time I really faced the harsh face of networking, of networks in production, and all the challenges that they bring. And I'm passionate about networks since very early on. So when I studied telecoms, I always knew I wanted to do networks. Don't ask me why, please. Okay. I'm also passionate about product innovation. So how to bring actually technology and the nitty-gritty and the standards and all this kind of stuff into something that actually makes it to the market, something that will resolve a problem to somebody. So yeah, trying to work on those lines. Zeetta, which is the organization I work for, is a software startup here in Bristol. It was founded in 2015, spin-off from the University of Bristol from High Performance Networks Group. Very clever guys there. And actually, we have a strapline, which is where we aim to change networks the way cloud changed computing. That's a very high rise objective. But yeah, we're working hard actually to achieve all that. So let me talk to you about building the unmanageable network, okay? Because we all are used to connectivity. We have networks everywhere. We are radiated with wireless networks and so on and so forth. But actually, networks are not so pinky, let's put it this way. Okay, so applications and technologies appear faster than network technologies actually can catch up nowadays. Okay, so since probably I'm gonna bet on something. But since the iPhone was launched and we had this portable computing platform for running applications, consuming contents very easily on our hands, and they started being connected to Wi-Fi and consuming stuff from the internet, then everything kind of exploded. Okay, so now and day after day we see more things connected to the network, not only Internet of Things, but also more devices at home. I'm pretty sure everybody has tablet, laptops, mobile phones, etc. So there are more and more things that are connected to the network, consuming and producing data, and that's putting stress on networks at all levels, since the one at home, in the enterprise, and the macro. Okay, and we keep connecting more and more because vendors keep integrating, little network interface cards in many things, so we can have many sources of data. We can actually better inform ourselves. We can make our whole environment smarter at home, in the street, in the office, wherever it is, in the industry, whatever it is. And this is not news. Network refresh budgets are actually tied, and they keep being tied because traditionally networks have been seen as a sunk cost. And it's fully understandable because you have to pay a lot of money for heavy iron, which is difficult to manage, and it's set to not to be changed. And we keep putting pressure on it because of the previous ones. And last but not least, of course, yeah, we end up upgrading networks as a patchwork. Okay, when we create a network infrastructure, we normally tend to go for a single vendor and for a very specific configuration. And then as time goes by, new things are required, new requirements on the infrastructure. So we end up buying different vendors. We end up buying, implementing designs from different people. We end up actually forgetting about configurations, and all of that goes against the way networks are operated. It goes against actually what the networks deliver, which is connectivity everywhere, whenever we want it. Okay, so in order to understand how this works in practice, I wanted to go very briefly on how do networks evolve. Okay, so the very first thing is actually the design. Yeah, there is an architecture that some network engineers, networks put in place, some dimensioning work trying to understand what the requirements of traffic that the network has to pass, regardless of the scale. Okay, it can be, this is done for the commercial off-the-shelf Wi-Fi access points at home to the very high-end telecom infrastructures. Okay, so the exercise is pretty much the same, completely different scale, completely different market, but it's the same. And then obviously at the end you have some design specs for the network infrastructure. So How is it going to deliver the connectivity? How many things? Where do the things have to reach? You know, the internet, cloud services, etc., etc. Then after that, after a successful design, then you go to the build phase, which is a bit tedious, but you have to go there into the market. You have to find out who actually can fulfill the requirements for your design and specs. You have to have discussions with the vendors, just try to make them fit into your budget, and try to compromise on the things that you really need compared to the things you can sacrifice because, yeah, actually the budget doesn't stretch out that much, and so on and so forth. Very boring stuff, but at the end of the day, it's already conditioning the way the network is built. So you have to play smart there. Then you go and then install the network infrastructure, so pulling cables, powering things up, racking and stacking things, as one of my colleagues at work says. And then you have to finally do the base configuration and power it up, so that you, if it's a Wi-Fi network, then you have Wi-Fi signal for your devices. If it's the termination of your network at home, that you can plug your router and then get signal and so on and so forth. Next one, which is even less interesting, it's operation. Although it's I would say it's probably the most the roller coaster of the whole process. Okay, it's operating the network infrastructure. This is where engineers actually do the configuration, have to make sure that the network is operating as expected, keep an eye on alarms, keep an eye on problems, do maintenance, and keep adapting the network to whatever the new requirements are. In this stage is where new applications and new technology are actually hit on the flotation line of the network. This is where these new requirements will actually affect the way network evolves a long time and how it's delivering its service. And the last step, so at some point the network will go out of life and has to be refreshed. So we need to reassess requirements. We need to think about the options on how we can upgrade and eventually build an upgrade project, which will bring us back to design and move on. This is the theoretical model, very simple one. But in reality, actually what happens is something more or less like this. Okay, so we have design, build, long operate, and a refresh with a question mark in the end. And the reason is because new applications just hit on the way of operations. Okay, so when a new application arrives, think about, for example, when Netflix first hit the market with all of that traffic flowing from the content delivery networks into the residential networks. There was already a stress that the network operator didn't plan for, and they had to adapt to that. The same way, when you have your Wi-Fi at home and you happen to buy the Wi-Fi a few years ago, and then you got this new device which works in whatever new standard of Wi-Fi, which doesn't actually work well with your old Wi-Fi access point, and your device keeps disconnecting. Okay, so those new requirements happen on the fly and affect your network infrastructure. The same way, I was about to say, shit happens. We have problems. Okay, something breaks, something actually is not quite working as it was expected, and it needs to be replaced or maintained or put out of service in order to be fixed, and then bring it back. And then all of a sudden, new technology appears. So you have to extend the capability because whoever bought these new iPads for the sales guys, actually they require whatever new thing on the network, and it was not there before. And maintenance again, and so on and so forth. So actually, all of these stages have a bit of design and build, and all of them change the way the network is, or require changing the way the network is while it is being operated. So it's really challenging for the network, actually, the hardware itself and the guys, the people taking care of the hardware, to adapt to new requirements. So when you get to the end of it, it's time to refresh. Okay, what do we refresh? When do we refresh it? Because we have a patchwork of a network infrastructure. Okay, think of probably this is most clear seen in an enterprise network. Okay? So some figures about the problem. IT teams spend over 70% of their time doing manual configuration tasks in the network infrastructure. Manual, by hand. Okay. In a network infrastructure at home, you can log in your Wi-Fi access point and do some changes. That's quick. Or you may even not have to do that at all during your whole lifetime of the box. But in an enterprise, that's challenging, okay? Because there are new things connected every now and then. And imagine the scale of this, in some cases, in an operator environment, okay? So this is terrible. And 87% of the IT managers feel that they are overstretched. No surprise, they are doing a lot of stuff by hand, okay? And that's actually driving them nuts, because they could be spending time doing something more profitable for the business, okay? Like thinking about security policies, preparing for the next wave of, ransomware that is going to attack all the devices connecting the network, or simply just thinking about how to do a proper refresh of the network infrastructure, and they are spending a lot of time in doing manual stuff. And the last figure, of course, which is probably the most difficult to swallow, is 80% of these errors are because of a human error. Again, that's a terrible figure to swallow, okay? Because all these guys doing all this stuff by hand, they don't do it because they want. It's because that's the tool they have. They have been given a network infrastructure which is a bit of a patchwork that cannot go down. There cannot be a blackout, because all the business services are running through that, and it's critical that we keep working operations. Imagine now with the lockdown situation, all of the systems that have gone online, all the people in the offices working from home simply cannot fail. But still, network has to be operated, and these are the appalling figures that are behind the operation. Okay? So what are the options? What can we do about that? First of all, live with it. And it sounds like a crazy thing, but most of the organizations do that. Okay? As I said, it's a difficult thing. It's either expensive, or it's either disruptive to get the network to go down. So you live with the problem, you keep patching it, and you pray that you have enough skills in house to keep it working and the business. And whenever a better time comes and there is budget available, then do a refresh, whatever it is. But this is a short-term solution, okay? You just keep working on the day. The things you have to keep working for the day. Tomorrow may be a completely different day, and everything may go down again, whatever. The biggest challenge with this is not actually the cost. It's actually how this affects users. Because running a network like that, keeping a patchwork and keep doing some tiny adjustment and bringing more vendors in and trying to fix the problems of the shortcomings from previous hardware or previous decisions, it really prevents you from accepting new changes. And one of the things that probably everybody has heard when having to engage with IT is, yeah, if the network works, don't touch it. Don't do it. Okay, that's why. I can come back to the previous slide, but no, I will not do that. Okay, so because there is a lot of process that still is done by hand. And don't get me wrong, things have changed a lot. Okay, there's an awful lot of capability now. A lot of vendors have included software to manage their own kit, but still, networks are not a single vendor. Okay, so another option, replace, which would be great. Okay, just get rid of everything, install new one. If you have deep pockets, probably that's your option, but it disrupts the business still. Okay, you will have to actually get rid of everything, do a new design, commission the new infrastructure, and start over. And by the way, you have to retrain your engineers, because chances are that probably you have selected a different vendor from the last time, because this is a more competitive market that is moving all the time. And what happens if you keep operating with the same strategy, by hand, manual operation, and if it works, don't touch it, you will recur. In the future, you will be exactly in the same position. Okay. So what's the third option? The third option is probably, no surprise, what we are trying to work on. And it's, okay, use software, evolve how you control your network infrastructure so that you can gain insights and make smart decisions and act smartly on the network infrastructure, okay? So many times when operating a network infrastructure, the problem, the real problem, the root cause of a network blackout is a silly thing. And there are stats over there. I cannot remember any of them, but there are stats over there. A failed backup at 3 a.m. in the morning that somebody forgot to press the button. It just tore down the whole network infrastructure the day after when everybody came back to the office. Okay? These kind of crazy things. So it's important to really find out what's the part of the network infrastructure of all these different technologies, all these different systems. What's the part that is really failing? Okay. And then try to resolve that and keep going, okay? And gain more insight and understand, expose all the capability of the network infrastructure to everybody which has to deal with it, not just with the engineer which has been there since it was designed, and build, or the person who has the most certifications in the team. Okay. So a typical architecture that is used, and this is an architecture we at Zeetta have been working on for a while, is to use to leverage on two things. Okay, to use open networking and leverage on software-defined networks, which is the not sure if you will be able to see my mouse, probably not, which is on the SDN controller box here. This is the actuator part. This is where we build software to tell all these different bits and pieces of the network infrastructure from different vendors, different technologies, how they have to be configured so that we can achieve something across all of them. Okay. Second part is obviously, once we have visibility on what's going on in the network infrastructure, is what do we do on top of it? We have to orchestrate all these different bits and pieces so that we can actually provision end-to-end. And this is a fairly typical architecture in the telecom industry, but it's not very well implemented in smaller scales, like, for example, enterprise networks. Okay, they're still very purpose-built in the network infrastructure. So what we are trying to achieve here is, we can build a software platform on top of the infrastructure that allows us the flexibility and the visibility end-to-end, so we can actually work on a raw material which is all exposed through standard APIs, open APIs, and it's programmable at the end of the day. Okay. And the last part of the story is probably the bottom right part, is the analytics. So one of the things that most of the network operations guys nowadays face is every single vendor, every single piece of network system that they have has its own monitoring system. And on top of that, they have to install other monitoring systems in order to be able to get all the details that span across the different infrastructures. We're not trying to replace that problem. That problem will always exist, because vendors have to provide you the best tools they have. Oops, sorry, what happened? I think you've lost my screen.
We've lost the slides, Joan, but we can still see yourself.
Okay, sorry, not sure what happened with our computer.
You're still connected.
Let me, oh, PowerPoint is playing games. Okay, sorry, let me just try again.
No problem.
Am I back?
You're back, yes.
Okay, sorry about that. Sorry, I think I lost my thread. Okay, yeah, so we are not trying to replace all of that monitoring capability, because the vendors have to offer the best for their kit all the time. But the most important part here is we have to tackle the problem from an end-to-end perspective, okay? In order to operate a network infrastructure, which is composed of many different things, we have to be able to collect insights and data from all of that, about the traffic that is passing the network, about the different nodes in the network infrastructure, and about every single component that is connected to that network infrastructure, and then make decisions on how to reconfigure the network infrastructure based on all of that information. Okay, this way we can close the loop. Traditionally, the way the loop is closed is actually going through this way, so going to manual network operations and going back then again. Okay. That's great, that works, but this means that we need a network engineer here, a human. Okay, that's probably it's very good if the APIs on top of the service orchestration are rich enough for these network engineers to have applications that allow them to operate the infrastructure with a lot of flexibility and for the needs they have. But most of the times, they have to spend their time trying to do repeatable things that are actions that are repeatable in the infrastructure, like, for example, setting up a Wi-Fi, configuring a VLAN, or checking that the backup of the device X was done on time. Okay. So we will have to get used at some point to something slightly different, which is the introduction of AI. And this is why this specific architecture is useful, because then when AI comes, which is on the way, then it will be able to replace parts of the operations that the network engineers do into something that gets rid of the provisioning, rollback, and error checking and root cause analysis on behalf of the engineer. Okay, I hope I'm not boring you a lot, so I'm going to move ahead. So what's actually the network automation journey? Okay. There are the way I discuss this with people all the time is three basic principles. Okay, automation is the end, or automation, sorry, is the end of this journey. It's the start of a new journey. But the very first thing you have to do is just see things. If you don't see things in your network, there's no chance you can manage it. Okay, and if you have to look at 7 different, 10 different, 15 different systems to understand what's going on in your network, that's difficult. Some point in the past, in conversations with Telefonica, again, I'm jumping into a different scale, but Telefonica in Spain, they run 390 different autonomous systems on their network, okay? And if one of these systems fails, they may not be able to build. They may not be able to monitor the light paths. They may not be able to deliver residential broadband. So it's really, really difficult. If you cannot have all of that visibility in one place and something fails, you are blind, okay? Then obviously the next thing is, if you can discover your network, just aggregate things together. That's what software for, isn't it? One, you have a model of the network infrastructure. One, you have a virtual representation for every single thing in your network. Then you can start building topologies that show across the whole network infrastructure. And we are used to talk about the network as an abstract entity, as a cloud, you know, as something that is probably a blurb of stuff that just gives us no connectivity. But unfortunately, there's a lot of complexity behind it. There are a lot of devices that are connected to each other, that are passing traffic, that are making decisions based on the configuration that somebody put on them so that you can actually get the connectivity. So it's important to bring all of that together so that you can make informed decisions. Then in that case, you can also identify configuration problems. Again, remember 70% manual configuration. If things are configured manually, chances are somebody forgot to take a note of that, okay? So maybe somebody has left some old configuration buried somewhere in the network infrastructure. You have to be able to identify that problem. If you don't see things end to end, if you don't see things in perspective, it's impossible to see that, okay? And the last one is actually, again, the last one that is not the least important is being able to track network assets, printers, phones, tills, iPads, everything that actually runs the application for the business. All of those things are normally referred as, you know, the mobile devices, things that are connected to the network. But those are the only reason why the network exists, because you have to pass traffic through them, or sorry, to them, so that you can do some sort of business process and then send it back, okay? Okay, that's the visualization part. So once you have a nice picture of your infrastructure, then you can start correcting configuration issues, which is, by the way, a very systematic process, okay? Check here, check there, do they match? No, next, okay? So it's, in many occasions, it's not really, really complex to do the optimization of network infrastructure. It's just a matter of having the right visibility and having the time to go through that systematically. Obviously, then linking the network configuration of those devices and that network into actually the applications running on the business is very important. So you need to have to also quality time as an engineer to think about that. Again, done by hand, that's a better way of doing it, okay? And the last one, yeah, you have to be able to test configurations with assurance. Just make sure that the next configuration you're going to push in the network on that device is not going to kill the whole network infrastructure. Okay, you can do some planning. You can make a plan about how to do that, and you can do your configuration upgrade at 3 a.m. in the morning. But still, if you can test it before you actually commission the whole thing, that's great. And that's something you can do also on software, and something that automation will be really useful for. And last, on this journey towards the baseline of automation is actually start doing things that are repetitive. You know, let the software do it for you, okay? As long as you can put the rollback process in place and you have a means of getting actual up-to-date context on what's happening in the network, okay, then let the network controller take the decisions and do the configurations for you. And yeah, many network engineers nowadays actually working on very sophisticated scripting frameworks, which is great. But again, the scripts can be automated, can be scheduled, but still they are scripts. So you have to be a very skilled scripting engineer so that you can actually adapt. Sorry, you can actually adapt to the changes in the context of the network infrastructure. the best you can do is actually not rely on scripting all the time. Scripting is good for certain set of tasks, but actually, if you have a control logic that can process inputs real time and can make decisions on whether what you are trying to achieve is good or bad, and you can then implement robot capability, which is intelligent, that's much better than relying on, scheduled scripts. And these open the doors for something which is sounds a bit esoteric, but making configuration changes in network infrastructure end to end. It's something that very little people do, okay? Because it's risky. Changing the end to end of a network infrastructure in order to push a service, it's risky. So if you can profile that and you have some logic that allows you to understand whether that's going to affect all the different systems on the way, that's great. And then the software, actually, the networking control platform software is the place to start with that. And last, and relating to the previous one, is, okay, once we have all of that, and you open the door for AI operations, you can start replacing some of the repetitive actions by some sort of intelligence that can also learn as it goes. Okay, as I said before, there are many actions on optimizing infrastructure which are systematic, so that's something that we can open the door for AI, and then we can use the engineers to actually deliver value to the business. Think about how to make the network work for the business better rather than trying to catch up all the time. That was my talk today. I hope I gave you an overall view on networks and how they are built and not how they work, but how they actually get to be there and how they are operated and what are the challenges behind that. So thank you very much for listening.
And I've unmuted you all so that you're able to show your appreciation. Thank you, Joan.